Hello, good morning, everyone. Welcome back to my YouTube channel. In today's video, we are going to solve today's problem. That is the maximum twin sum of a linked list. In a linked list of a size n, where n is even, the ith node zero index of the linked list is known as the twin of the n minus one minus ith, or uh, I should lies between the zero and n by two minus one. And this is called as the twin. So this is basically the definition of twin. Let me simplify this definition for you. If we are given an array, yeah, if we are given a linked list of 5, 4, 3, and 2. So what is the meaning of twin? 5 and 2 is considered as twin, and 4 and 3 is considered as twin. So if we are going to check the definition, that is, if it's 0 index 0, 1, 2, and 3, and what is the number of nodes, n is 4. So the twin is, if I equal to 0, then we can define the twin as n minus 1 minus ith term, that is 4 minus I minus 0, that is third one. So you can see that 0 and third one are called twin. So 0 and third, that is 5 or 2, is called considered as twin. So this is the definition of twin. Now we have to find the maximum twin sum. So we just have to find the maximum twin sum. So here you can see that the sum of these twins are 5 plus 2, that is 7. 4 and 3 is 7. So the maximum sum that is possible by summing all the twins is 7 only. So the our output will be 7. Let us try run some other test cases of lead code. So we are given 5, 4, 2, 1. As you can see that we are given with 5, 4, 2, 1. So the sum of 5 and 1 is 6. 4 and 2 is 6. So the maximum sum is 6 only. So the output is 6. 4 and 3, the sum is 7. And 2 and 2, the maximum is 4. So the maximum output of 7 and 4 is 7 only. So we get our output. Let us, what should be our approach to solve this problem? So the very first approach we can do is the brute force. In brute force approach, what we will do, this is our linked list 5421. First of all, I will store every element in uh, in 54 and 21, and then I will just start comparing the leftmost and the rightmost index. This is 5 plus 1, that is 6. This is 4 plus 2, 6. So by using an array and a two pointer method, I can solve these problems. But by solving this approach, we can get our time complexity will be big of n only, but our space complexity will be big of n, because we are going to use an extra space. The second approach that we can solve this problem is, we are given the linked list. If we are not going to convert it into the array, so what we can do is, I will create a copy of 5421, not a I have to create a deep copy of this element, and I will reverse it 1, 2, 4, and 5. Then I will just start iterating. This will be 5 plus 1, 6, 4 plus 2, 6, 2, 4, 6, and 5, 1, 6, because every element will be mapped with its twin only. So even if we traversed half of the index, then we can find our array. Then we can find our output. But the issue by solving in this approach is also that we are going to create a deep copy, not a shallow copy. We are going to create a deep copy of the linked list, due to which it will also require a big of n space. So is there any approach by which we can solve this problem in big of 1? Yes, there it is. It is called as a Floyd cycle algorithm, or we can say it is called as the hare and tortoise method. Plus, obviously we will use the function of reversing the linked list. So let me tell you about this approach and how we are going to solve this. So in this approach, we are given with 5, 4, 2, and 1. First of all, I will find the mid of this mid of this linked list. What will be our mid of the linked list? By using a hare and tortoise method, or we can say it is a Floyd cycle algorithm. So our hare will point into this index. Okay, and it is a even list. So we have to find the mid minus one. So you can see that 0, 1, 2, and 3. Our n is equal to 4. So our mid actually will be 4 by 2, that is 2. But I don't have to find the 2. I have to find the first index. So our here will be point to this index only, and our tortoise will, sorry, not here, it's tortoise. So our tortoise will be pointing to this index, and our here will be pointing to this index. Now I will start iteration till here complete iteration, or it completed the linked list, or till the pointer points to the null. So after the first iteration only, here will be we will move this here pointer with two index, and this with the one index. So after first iteration, here will be here tortoise will be pointing to 4, and here will be pointing to the null. So we have found our mid. After finding the mid, what we are going to do, after finding the mid, that is 5, 4, 2, and 1, this is our mid. After finding the mid, I am going to reverse this list. After reversing this list, I will get 1 and 2, and this will be 5 and 4 only. Now I will start iteration of this linked list. This is 5 plus 1 will be 6, and 4 plus 2 will be 6. And I have to report the maximum of this twin sum. So after this approach, I will get a 6. And by this approach, we will get the time complexity of big of n, and the space complexity of big of 1, because we have not used any extra space. Instead what we have done, we have just um, modified the linked list by this will be pointing to the null, and I'm just going to reverse this linked list, that is 1 and 2. Now I will start iteration 5 plus 1 and 4 plus 2. So we have just divided the linked list into two parts, and we reverse the next half of the linked list. So let us see how we can write the code of this problem. So as you can see that this is our temp, and this temp is nothing. It is our what we can say. It is our hair. Not hair. I am just confused between the hair and tortoise. It's tortoise, okay? And this is called as hair. So our hair will be moved by one pointer, while our tortoise will be moving by by one index, and our hair will be moving by the two index. By this approach, we can find the mid. After finding the mid, I'm going to reverse the half of temp dot next. It means that what I'm going to do. This is 5, 4, and this is 3, and this is 1. Okay. So I am here. My temp is pointing here. So what I'm going to do, I'm going to reverse this part. I'm going to reverse this temp dot next. So after this reversing, my half will be pointing to 3, and my half will be pointing to 3 only, and my temp is currently pointing to 4. But as you can see that I will just start a new our head is still pointing to the 5 only. So I will just start iteration till while first half is not null. I'm just going to add the first half value and the second half value, and I will just maximize my result. By this approach, I will get my result. And this is the code of reverse function. How we are going to reverse this function. So this is the only prerequisite that you should know to solve this problem. By using this approach, we can solve this problem in time complexity of big of n, and time complexity of big of n, and space complexity of big of 1. So let us submit this problem on the lead code. So yeah, as you can see, this is successfully submitted on the lead code. Thank you.